Hi guys, it is Ms. Selman here, and I just want to go over topographic maps with you just in case you haven't been to Zoom or if you just need a refresher. Either way is okay with me. So first I want to show you this picture of the Grand Canyon. So this is just a normal photograph of the Grand Canyon. If you have never been there, I highly recommend you go, but just in case, this is a photo of it. It is one of the 7 natural wonders of the world because look at it, it is beautiful. What has happened is over time, the Colorado River has carved through this canyon by weathering and eroding away a lot of that sandstone there. And we have some pretty dramatic elevation changes, which if you don't know, elevation is that difference in height above the sea level. So here we have some pretty dramatic height differences from the top of the canyon right here, all the way through to the bottom of the canyon down here. Now, this is great and all, but how can we represent it visually on a 2-dimensional flat piece of paper? Well, the way that we do that, the way that we represent those big dramatic elevation changes is through this thing right here. This is called a topographic map. And a topographic map uses these contour lines, which are these brown lines here, to visually represent those changes in elevation. So each one of these contour lines represents an area of the same elevation. So everything along this same contour line here has the same elevation, meaning it's the same height above sea level. So this is a topographic map, and topographic maps can show us amazing things about our Earth's surface. So it can show us those changes in elevation. It can show us geological features such as mountains, hills, slopes, which is that steepness of the land, our rivers, lakes, valleys, etc. Anything you can think of using these contour lines here, which, just a refresher, those contour lines are these big brown lines here. The closer those contour lines are together, so like right here, if we're looking right here, those lines are super close together. That tells me that there's a larger elevation change in a shorter distance. So that means that my slope is much steeper. If it is more gradual, like it is right here, that tells me that my slope is more gradual. It's going to be much easier for me to hike this direction right here compared to something right here. And that is due to the steepness of that slope. Contour lines have 4 important rules, okay? So the first one, every single point along a contour line represents the same elevation. So if we look right here, we have 2 different elevation measurements on the same contour line. So that is telling me that this is not correct here, okay? So this is wrong. It needs to either be 1400 or 1300, but it cannot be both. All contour lines eventually connect with themselves. So if we're looking right here, we can see that these contour lines are connecting with themselves. But it's a little difficult to tell this sometimes. You might be thinking, well, right here, Ms. Selman, those contour lines are not connecting with each other. And that's just because we have zoomed in on this map. If we zoom out, eventually those contour lines will connect with each other. And then contour lines never, ever cross each other. And that makes sense because everything along the same contour line has to have that same elevation. So if we look at this map right here, we see that 2 of these contour lines are crossing each other. That is a big, big no-no because that would mean that this one point has 2 different elevations, which is just not possible there. And contour lines will never split up or branch off from one another. It will always just remain one line that does not touch the other lines. And now let's move on to contour intervals. A contour interval is that distance between contour lines. So let me go ahead and get out my annotation tool here, and I will go ahead and show you this in red. The contour interval is the elevation change between those 2 contour lines, and it will be the same for the entire map. So what that means is that every single distance between each one of these contour lines, no matter how close they are together, that has the same elevation change. The way that you find the contour interval is by a very, very simple calculation. So you find these index contours, which are these lines that give you numbers. All right, so in this case, we have 7,800 here and 8,000 here. So that is going to be the top of my fraction. So 7,800 minus 8,000. Sorry about my handwriting here. So that is going to be the top of my fraction. Then I'm going to count the number of lines between those two index contours. And that just happens by counting 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there are 10 steps between these two index contours, which if we follow this line here, that shows us 8,000. So we are going to divide by 10. What this is going to give us is our contour interval. So 7,800 minus 8,000. The difference between those two numbers is going to be 200. I know that I wrote that backwards, but you know, sometimes we just make mistakes. So the top of my fraction is going to be 200. And then the bottom of my fraction is going to remain the same. That's going to be 10. So this means knock out the zeros. So we have 20. That is the answer to our fraction here. So 20 is our contour interval. In this case, this was given to us on this map, 20 feet, but it will not always be given to you. So you will have to do this calculation here. Let me clear my drawings. And now let's do a little more practice with this. So this is another example of a topographic map. And right here is our labeling. So right here, it tells us what a contour line is. That is each one of these lines. We have the index contours labeled, which are those big, fat, bolded lines, and our contour interval. Notice how it's pointing between those two lines. Let's calculate now the contour interval of this map. So the first thing we do is we identify two lines that have our labeling. So we have 100 here and 200 here. So that tells me that the difference between that is going to be the top of my fraction. In that case, that will be 200 minus 100, which will leave me with 100. Now the bottom of my fraction, remember, that is the number of lines between these two. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Oops, that's supposed to be a 10 there. So I am going to divide by 10. The answer to this fraction is going to be my contour interval. So I'm just going to cancel out those zeros there, and that is going to leave me with a contour interval of 10. In this case, I do not have a unit because there is no unit listed. However, if I were told that these elevations were in meters or feet, that would give me my unit. So let's say that this is 10 meters. And notice that there is a space between the number and the unit. That is just something that is universally accepted in science. That is how you notate units. Remember, there is a space between your number and your unit. All right, so one more time. Let's try this one more time. This is something that you should be familiar with here because you have seen this on your quiz from Monday. So this right here, let's calculate that contour interval. First, let's find those index lines. Right here we have 40, and here we have 30. So the difference between those two is going to be the top of my fraction. In that case, it will be 10. Now we count the number of lines between those. So that's going to be 1, 2, 3, 4, and 5. So that bottom of my fraction will be 5. 10 divided by 5 is equal to 2. In this case, we have feet. So this is going to be 2 feet. and that is my contour interval. Now I also want to point out here, clear my drawings there, I also want to point out that these lines here are much closer than these lines here. Even though they represent the same elevation change, in each case they represent 10 feet of elevation change. That tells me that if I were to try to hike up this one right here, let's refer to this as A. If I were to try to hike up A, it would be much steeper, so it would be more difficult to hike. However, for case B right here, those lines are further apart, so that tells me that it's a more gradual slope. So it would be much easier to hike up B than it would be for A. All right, so I'm going to clear my drawings there. And I believe that is it. I hope this helped you. If it doesn't, please make sure that you come to Zoom or send me an email. I will see y'all later. Bye, guys.